and horizontal asymptote. Everything else is the same. We are finding limits like before. We are finding x and y intercepts like before. We are finding critical numbers like before. We are studying the sign of the first derivative. We are finding inflection points if they exist. We are studying the sign of the second derivative. Everything is the same. In addition, it's this, which is a horizontal asymptote, unless they are infinity. If they are infinity, there is no horizontal asymptote. And it's this that is the vertical asymptote. That's the only difference. But, of course, I had to explain all this and the limits and so on and so forth. So it took me 3 pages. So I finally graphed it because it's more intense. How do you feel about this problem? Any questions before we choose another? Any questions for me?
Are we going to be graphing like things with more steps?
No, this is it. That's the top. There is nothing else. I promise you, this is it. Once we work on and you redo this problem, you're going to see how things will start clicking. Okay, so let's work on one more. I would like to choose, yes, we can work on the natural log if that's what you want. Slightly different, maybe a little bit less work in a way. But what I would like to do is work on 43. Or you can directly go to word problems. They're all the same. I'm not going to ask you to graph. Okay, you don't have to graph. We can graph and look at the graph with the graphing calculator. But these are more important. I'm interested in domain. I'm interested in max min that you can determine by hand. But the graph will be a little bit more involved. We can, but I'm not asking you to graph.
I have a question.
Yes?
For the question number 2 that we just did.
Yes, as I said, it didn't ask for that. I said I'm going to do the whole thing. Yes.
Do we need can we double check the graph in on the calculator?
Oh yes, of course. Yes, of course. Yes. Thank you for reminding me to do that. So don't forget parentheses, 2x minus 3. And parentheses for the denominator, these are a must. There is no way around that. And of course, the horizontal asymptote, the graphing calculator will not put it in without us putting it in. Okay, so I'm going to use Zoom 6, the standard viewing window, because I already graphed the function. I know where the asymptotes are. They will be in the viewing window for the standard. Negative 10, 10, negative 10, 10. Here it comes. Aha, that's it. What the graphing calculator is not graphing is the vertical asymptote at x equals 5. Maybe there is a way to put it in. The less sophisticated calculators were putting it in, but the higher end ones don't. Rocky, was this your question, or did you have something else?
Yeah, this was it. I was just wondering if we can check it.
Oh, yes, of course. Yes, thank you for reminding me. Absolutely. Okay, so let's take a look at, do we want to work on another problem now, or you want to work on a word problem? What would you prefer?
Can we just work on like a normal one?
Yes.
Non-word problem?
Yes, yes. It will go much faster because I have so little to explain now. So let's look at 43. Slightly different. You'll see in a moment how slightly different and why I say that. So this is x squared plus 2x minus 15. Awesome. Good. What is the first thing we need to start with? Always. And then the table. What is the first thing? Always, always, always.
Domain.
Yes. So can anyone tell us what we need to do before we establish the domain?
Find out the bottom.
Awesome.
X plus 5, x minus 2, or 3.
Good. So can anyone tell us the domain? In plain English, everything but.
-5 and 3.
Very good. Awesome. Remember, 0 has to be in the table no matter what. Again, these bars just say you cannot put anything in there. The function doesn't exist. Notice that intentionally I covered the numerator. Now, let's take a look, because I have to establish the domain before I touch the function in any way or I change the function in any way. Not factoring, but just not simplifying. What can you say about this? Is there anything that can be done here?
X minus 3 is cancel out.
So the simplified form is 1 over x plus 5. See this factor that went away? That factor creates a hole. See the factor that stayed and I couldn't be simplified with anything? The factor that stays creates the vertical asymptote. The factor that disappears creates a hole in the graph. That was the only different situation than the problem we looked at before. So can anyone look at this function and tell me what I should write under 0 by plugging in 0 in there?
1/5.
Very good. Awesome. Can anyone tell us the limits at infinity? Can anyone plug in infinity or negative infinity and tell me what to write here and here? I have a cake and I want to share it with the entire globe. How much will I... So how much will you get when I get to your door?
It'll be 0.
Yes, of course. There's nothing. When x approaches negative infinity in the denominator, 1 divided by infinity will always be 0. Good. Can this be 0? Can 1 over x plus 5 be 0? In other words, is there an x-intercept? When the numerator cannot be 0, the fraction cannot be 0. The only thing I'm missing is these limits. So I have to find a limit as x approaches -5 from the left, -5 from the right, +3 from the left, and 3 from the right. And I finished this. It took us like less than a minute to do this, because now we know what we're looking for. So let's find these limits, and I can immediately continue with the first derivative. What took us 20 minutes before, it will take us 4 minutes now. So then I have limit of 1 over x plus 5. Be careful, this is gone. I already established that there is a hole there. I don't go back to differentiate this. I don't go back to look at any of this. This is gone. I'm only looking now at the new simplified form. From here till here, I already established everything that needed to be established. Now I'm working on the simplified form, moving forward only. Okay, so the limit as x approaches -5 from the left, and the limit as x approaches -5 from the right, and then the limit as x approaches 3 from 1 over x plus 5. Left and right will be the same, but never mind, let's write it. Okay, let's start with the easy one. Can anyone give us this limit? It's okay if you're wrong. You couldn't be.
Is that 1 over 8?
That's it. That's it. Good. So now let's determine this. The numerator is positive. I wanted to write it here, actually. And plug in a number from the left of -5 and give me the sign. Because we know it's over 0. I mean, there is no discussion there. We knew that. It's a vertical asymptote. So that's not a secret. But I just need the sign. So -5 from the left.
Positive?
Yes, it's -5.1, right? -5.1. So this will be negative infinity. And here with -4.9.
Infinity.
That's it. I found something. I found something. I found something. I have to put them in the table immediately. Now I'm ready to differentiate. So 1 over, so f of x is 1 over x plus 5, or x plus 5 to -1. And we want to differentiate f prime, -1, x plus 5 to -2, times the inner function prime. What is that? How much is the inner function prime? When we differentiate x plus 5, what do we get?
1.
That's it. Can anyone look at this function and realize that it's never 0, never undefined, because it's undefined where the function is undefined, and give us the sign of this expression?
Negative.
Always negative. I found something. I found something. Good. So then the function is always decreasing. So now I'm making sure that these two work well together.
Can you explain that one more time real quick?
Yes. So the first derivative is a fraction. The fraction will be 0 only if the numerator is 0. It can never be 0. 1 can never be 0. So this is always a positive number. There is a negative sign in front. This is always positive. Positive of a positive with negative in front will always be negative. And there are no
Okay.
critical numbers. So then I found that out and I put it in the table immediately. Now, from 0 to -infinity, yeah, that's true. From infinity to 0.2, yes. To less than 0.2, yes. To 0, yes. It's supported by the sign. Sorry. Always decreasing. Now I want to see what happens here, and it's done. So I need to differentiate this. And I have 2 x plus 5 to -3 times the inner function prime, which is 1. I shouldn't even write it. So this is 2 over x plus 5 squared times x plus 5. And you can say again, what are you doing? Why can't you just write x plus 5 to the third? I can. But I want to quickly find the sign of this expression. Can anyone tell us what is the sign of this piece, first of all?
Positive?
This is always positive, so I don't need to look at it. The sign will be given by this, and of course it's never 0. But now this quantity can be positive or negative. So I go back to my table. before -5, where it's 0. Before -5, I need a sign. After -5, I need a different sign. Can anyone give us the sign before -5?
Negative.
Can anyone give us a sign after it's 0, after -5?
Positive.
That's it. That's all I needed. Does not hold water, holds water, holds water. This time it took us half a page, or a page if you want, because we already know what we're looking for, and it's so much easier now after we looked at the first problem. Everything is gibberish except my table. Nothing matters. Everything is in the table. Okay, so there is 1, 2, 3, 4, 5. There is 3,1/8. Forgive me, it's going to be hard to present 1/8. And 0.1/5, a little bit higher. And now I follow my table, of course, after I present the horizontal asymptote. But that's an overkill because it's the x-axis. But I'm going to write it on the side so I know it's there. From 0, decreasing, opening down towards -infinity. Oh, easy. It does not touch the asymptote. From +infinity, crossing the y-axis, going through the hole, approaching 0, all opening up, all decreasing. Easy. I didn't mean this to be an open point, of course. Sorry. So this is smooth, not continuous because it has a hole, and that's it. So this is f of x, the original function. Now I can write here the original function. There is a big issue here with the graphing calculator. Big issue.